In this video, let's explore the concept of friend functions in C++ programming. Friend functions provide a mechanism to grant non-member functions access to the private and protected members of a class. This can be useful in certain situations where you need to bypass the normal encapsulation rules of a class. It's like giving a special key to a function, allowing it to unlock and use the private parts of a class. We'll dive into what friend functions are, how they work, and when to use them so you can add this powerful tool to your C++ skills. Friend functions are special functions in C++ that, despite not being members of a class, are granted access to the class's private and protected members. This is achieved by declaring them as friends within the class definition, using the keyword friend. Think of it as a controlled way to break encapsulation, allowing external functions to interact with the internal workings of a class. Essentially, the class is saying, I trust this function even though it's not part of me. Here's an example. We have a class box and a function calculateArea which is declared as friend inside the box class. Now let's see how to implement a friend function in C++. First, declare the function as a friend inside the class definition. This tells the compiler that this non-member function is allowed to access the private and protected members of the class. Then define the friend function outside the class, just like any other regular function. When writing the function, you can directly access the private members of the class object passed as an argument, without using getter or setter methods. One thing to note is that you don't need to use the scope resolution operator to define the friend function, because it is not a member function of the class. Also, there is no this pointer inside friend functions. In this example, you can see how calculateArea is implemented. Friend functions should be used judiciously, as they can weaken encapsulation if overused. However, there are specific scenarios where they can be quite useful. A common use case is operator overloading, especially when the left operand isn't a class instance. For example, overloading the output stream operator to print class objects. They're also handy when you have functions that need to work with multiple classes and require access to their private members. Furthermore, they're sometimes used in testing to directly examine the internal state of a class for verification purposes. And lastly, friend functions can aid in performance optimization for certain operations by eliminating the overhead of calling getter and setter methods. As an example, the code on screen shows how the plus operator can be overloaded for a class complex as a friend function. Friend functions are particularly useful when working with multiple classes that need to interact closely. A friend function can be declared as a friend in more than one class, granting it access to the private members of all those classes simultaneously. This is beneficial when implementing operations that involve objects of different classes, such as converting between class types, comparing objects of different classes, or implementing utility functions that work with multiple related classes. Let's consider the case of calculating the distance between a point in 2D space and a point in 3D space. The distance function is declared as friend function in both the classes point2D and point3D. Like any programming construct, friend functions have their advantages and disadvantages. On the plus side, they enable functions to access the private members of multiple classes, simplify operator overloading, and improve code readability in certain cases. On the downside, they break encapsulation, can make code harder to maintain if overused, increase coupling between classes and functions, and mean that changes to private members can affect friend functions. As you can see in the code example, declaring print details as a friend function is not the best approach, since it can easily be implemented as a class method. To make the most of friend functions while minimizing their drawbacks, follow some best practices. Use them for non-member operator overloading, when a function needs access to multiple classes, for specialized utility functions, and when implementing mathematical operations. Avoid them when a member function would suffice, when public getters and setters would be cleaner, when they create unnecessary coupling, and when they expose implementation details unnecessarily. Friend functions provide a controlled way to break encapsulation when necessary. Use them judiciously to maintain the balance between functionality and maintainability. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.